Okay, so one of the techniques we can use to solve systems of equations is to graph both lines. And so in order for me to do that, I want to actually put these in y equals mx plus b format so that it's easier for me because then I can find my slope and my y-intercept and then I can solve that like that, and then I can graph those two lines. So I'm going to get y by itself in both of these lines. I'm going to start with the first one. So I'm going to add 3x to both sides. So then I get 2y equals 8 plus 3x. And then I need to divide both sides by 2. And then I need to, so then I get y equals, okay, 8 divided by 2 is 4, so I get 4. Plus, and then 3 divided by 2 is 3 over 2x, or 1.5x, either one is fine. Next thing I need to do is I need to do the same thing with the second equation. So I need to get y by itself, so I'm going to subtract x from both sides. And I get 2y equals negative 8 minus x. Divide both sides by 2. And I get y equals, this time negative 4 minus 1/2 x. All right, so then I need to graph these two lines. So I'm going to start with the blue one. So my y-intercept is 4. My slope is 3 over 2, so 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And then I can follow that pattern back this way also. Whoops. Right there, and right there, and right there. It's a really good habit to draw your lines as far up and down on the graph as you can so that you make sure that you show the whole picture of what's going on. So connect these dots, looks like that. Okay, that's the blue one. Now let's do the red one. Y-intercept is negative 4 this time, slope is down 1 over 2. Again, I'm doing all of this so that I can really see the picture of what this relationship looks like. So then I'm going to connect these dots. Where is the solution? The solution is where the graphs intersect. So the solution is the point negative 4, comma, negative 2. This is the x value, and this is the y value. So if I'm asking you what is x, what is y, then I need you to tell me x is equal to negative 4, y is equal to negative 2. You can also give me the coordinate point negative 4, negative 2 as your solution. Okay, for this one, I'm going to start on the screen and then I'm going to show you a video of how I would do this in the graphing calculator. I'm going to start with the same step where I get y by itself in both equations. So over here, I'm going to subtract x from both sides, and I would get negative 2y equals 4 minus x. Then I need to divide both sides by 2, sorry, negative 2. So then I get y equals negative 2 plus 1/2 x. Going to do the same thing over on the other side for this equation. So this time I'm going to subtract 3x on both sides. And then I'm going to be done. So I'm going to get y equals 5 minus 3x. Okay, so now I'm just going to highlight the fact that I now have this one with y by itself and this one with y by itself. That's going to let me put these into my graphing calculator. So watch the next part, and I'm going to show you how to do that as well as solve this with your TI-84.
Okay, so I'm going to solve this system of equations that we got by solving for y on both of the equations with the graphing calculator. So I'm going to start by pressing y equals. I'm going to type in this first equation. So negative 2. Make sure to use the negative key, not the minus. You'll get an error if you use the minus. Negative 2 plus This time I'm going to do something fancy to get a fraction, so I'm going to press alpha y equals, and then enter. Then you can type in 1 over 2, and then the x is right next to the alpha button. Then I'm going to click down, and I'm going to type in 5 minus 3x, 5 minus 3x. To see those two lines, I'm going to click graph. If you have one of these color edition ones, then you can see the colors matching up with the two equations here, so the blue one and the red one. Then I'm going to calculate second trace, which is the calculate menu, an intersection, because I know that the solution is where the graphs intersect. So again, that's second trace and then intersect, which is option number 5. First question is, what's the first curve or the first function that we're using? You can just hit enter. Second curve is, you can hit enter again. So hit enter twice and then scroll to where the intersection actually is. That's what guess means, is show me where I should be looking, and then hit enter one more time. And then it gives you your solution right here. So it says x is 2, y is -1. And so we'll use that information in a second.
So then if we get our answer as x equals 2 and y equals -1, then our solution is the point 2, -1. There's our answer. We used our graphing calculator with the second trace menu, that's the calculate menu, to find an intersection, and that is how we get our answer this way. There are 3 different kinds of solutions that you can get when you solve these equations. These systems of equations, you can get intersecting lines, which is what we've seen in the last 2. You can get coinciding lines, where the 2 lines that you graph are actually on top of one another and they're the same, and you can have infinitely many solutions then. And then you can also have parallel lines where they never cross. There are some vocabulary words that we use to describe these types of systems. If you can find a solution, which means any solution, so you could find one or you could find infinitely many, we call that system consistent. So that means you actually can get a solution. If you don't get a solution, that's the parallel line situation, then you would call that system inconsistent. If the 2 lines are the same, then we call them dependent. If they are not the same, then we call them independent. So kind of a lot of vocabulary words there, but what's really important is that sometimes you can get 3 different kinds of situations coming out. You need to know that consistent, independent solutions are the ones that we're going to see the most of, and that's where the 2 lines are going to cross in one place. Okay, so now I'm going to jump into some solving with algebra, and that means using the symbols to get values for x and y. So you probably have seen these 2 methods before. The first one I'm going to show is substitution. This works really well when it's easy to get a variable by itself. This one already tells me, hey, y is equal to 4x. So wherever I see y, I could just write 4x. So here's a y, here's a y. I'm going to take this 4x, because it says y is 4x. Y is equal to 4x right here. Take that y is equal to 4x and just put the 4x where the y was. So instead of writing -2x plus y, I'm going to write plus 4x equals -4. That was right here. This is the substitution. Now I have something that I can combine like terms on. These 2 are like terms because they both have x's. How many x's do I have? I have -2x's plus 4x's, so I have 2 x's. Then I'm going to divide both sides by 2. And I get x is, -2. That seems like an answer. I'm not done yet. I'm going to take my x is equal to -2, and I'm going to substitute back for somewhere where I see an x. This x looks like it's pleasant for me to work with, so I'm just going to take that equation and say y y is equal to 4 times, not x, I'm going to write negative 2 because I know that x is negative 2. Well, 4 times negative 2 is negative 8, so y is negative 8. There's my answer for y. I need to write my answer, which is negative 2, negative 8, those two answers as a coordinate point. Write your answer as a coordinate point. We always write the point x comma y. And so if I know that it's xy, then I just need to write negative 2, negative 8. And there's my solution. This is my answer to this system. I'm going to do the same strategy here. I'm again going to do substitution, but I need to get a variable by itself first. So the first thing that you have to do is get a variable by itself in one of the equations. The one that looks like it's going to be the easiest to me is this y right here because it's all by itself, and it looks like I'm just going to have to make one step to get y by itself, isolate y. So I'm going to add 2x here, add 2x to both sides. Remember, whatever you do to one side, you have to do to the other side. You get y equals 4 plus 2x. Okay, I have this information now. Y is 4 plus 2x. I'm going to substitute it. I'm going to substitute this stuff where I see a y in the other equation. So step 2 is substitute into the other equation. Okay, so then I'm going to rewrite, so I get 3x plus 2, not y, but 4 plus 2x equals 1. Then I need to distribute and combine like terms, so I get 3x plus 4, just kidding, 2 times 4 is 8, 2 times 2x is 4x equals 1. Then I need to solve this equation. So I'm going to combine like terms. So this 3x and this 4x is 7x's. And then I have plus 8 over here. So then I'm going to subtract 8 minus 8, and I get 7x equals negative 7. Then I'm going to divide both sides by 7. And so then I get x equals negative 1. There's my answer for x. I'm not done, because now I have to substitute my x is negative 1 into, it doesn't matter which equation I use here, so I'm going to just grab, I don't know, this one. So step 3 would be to substitute the value into one equation. Okay, so then I'm going to take my negative 1 and put it in for x right here. So I'm going to rewrite negative 2 times, negative 1 plus y equals 4. Negative 2 times negative 1 is positive 2 plus y equals 4. So then I need to subtract 2, and I get y is equal to 2. There's my answer for y. So now write it as a coordinate point. Step 4 is to write it as a coordinate point. So then I get the point negative 1, 2 is my answer. Okay, the other strategy that you may have heard of is called elimination. And in elimination, our goal is to find an opposite pair of coefficients. And when I say opposite pair, I mean like 4 and negative 4. And I say 4 and negative 4 because they're both on the x, but they're opposite. One is positive, one is negative, but they're the same number, 4 and negative 4. If you add these two equations together piece by piece, you'll notice 4x plus negative 4x is 0 x's. I don't even have to write 0 x's, I could just write nothing. Okay, then I get 2y plus 3y, and so I get 5y's equals 9 plus 16 is 25. If you divide both sides by y, or by 5, excuse me, then you get y is 5. Ooh, that's nice. Now you can take this 5 and again just substitute into, it doesn't matter which equation you use, but substitute that in and then solve for x. So I'm going to do that over here, and we get 4x plus 2, but this time I'm going to write 5 equals 9. Now I'm going to simplify a little bit and then solve for x. So 2 times 5 is 10. Minus 10, minus 10. And we get negative 1 equals 4x. Divide both sides by 4. And we get x equals negative 1/4. This might be the first time that we've gotten a fraction answer today, and that's fine. There's nothing really wrong with that. There are fraction answers, there are decimal answers in the world, and so we want to make sure that we are kind of flexible and able to work with those. So our answer is negative 1/4, 5. This one I want to eliminate one of the variables here also, but this one just takes a lot more steps. So what I'm going to think about is like, what is easy to get rid of here? And it's kind of like nothing. Nothing is that easy to get rid of. So I'm going to do a little bit of a kind of a clever thing here. I'm going to multiply this one by, on both sides, by, let's say, negative 3. And I'm picking negative 3 because it's the opposite of this. So now that's going to give me negative 6x minus 21y equals negative 12. Now I'm not quite there yet, but I could take this equation and multiply it by 2. And then that would give me, ooh, look at that, 6x plus 10y equals negative 10. Now I have a system that is equivalent because I just multiplied both sides of both equations by different things. I didn't change the value of either equation, but now when I add these two together, these two x's, they eliminate, they add to 0. So then I can add these together and I get negative 11y equals negative 22. And when I divide both sides by negative 11, I get y equals 2, positive 2. Again, I can just take my y is 2 and put it in for either equation. It doesn't matter which one I use. And then I can solve for x. So 3x plus 5, but instead of writing y, I can write 2 equals negative 5. 5 times 2 is 10, so I get 3x plus 10 equals negative 5. Subtract 10 from both sides. I get 3x equals negative 15. Divide both sides by 3, and I get x is negative 5. Again, write your answer as a coordinate point, so your answer is negative 5, 2. Now this was a little bit more work, but I took these, I chose these by looking at these, because I knew that if I took these numbers and multiplied them respectively by these numbers, I would get opposites here and here. So that was my strategy to eliminate the x's. You could have done a very similar thing with the y's, and it doesn't really matter which one you choose. You'll get the same answer. The question here is like, what is the best strategy for this problem? Substitution or elimination? For this one, because I see this opposite pair of coefficients, I know right away if I take these two equations and add them together, then I will eliminate the 3y and the negative 3y. So elimination works really well for this one. You certainly could get x or y by itself in either equation and then solve that way. And that would work too. And that, there's nothing wrong with that. This one just seems a little bit more efficient to do elimination. I have my kind of like, when would you use which strategy slide here. I use the word easy not to say like these problems are easy. I'm saying easy by when I say not a lot of steps. For example, this equation is easy to get y by itself because I can just subtract 2x from both sides. And then I get y equals 4 minus 2x. That's only one step, and now I can do substitution. I can take this 4 minus 2x and put it back in for y here. The next one is sort of easy to eliminate the y's. If I took this equation and multiplied by 2 on both sides, then I would get this. I would get 2x minus 2y equals negative 8. Now this and this, if you add them together, you would eliminate the y's because I have a negative 2y and a positive 2y. So not a lot of steps is what I mean when it's easy. Okay, so you can kind of think critically, like what is actually going to be not that many steps for me to get an answer out. Just start to kind of play with the patterns and see what happens. Either strategy will work on every single problem. It doesn't matter which one you choose. Ultimately, some will be faster and some will be longer if you choose different strategies, but you'll get the same answers. So today we worked on solving systems of equations with graphs by hand with the graphing calculator, and then we worked on substitution and elimination. You're going to have a little bit of practice, and then you're done for the day.